Good evening, everyone. Welcome to the Kubernetes Sri Lanka. Today we have Ajanth, who is an intern software engineer at K8s Auto. He's going to talk about K8s Autoscaling using KEDA HTTP. Ajanth, the screen is yours, man.
Okay. Hi, everyone. Let me share my screen. One second. Is it visible? No.
Yes.
Okay. So before going on to why, before going on to using KEDA HTTP, the question is like, why do we need to use KEDA HTTP, right? Or why should someone try this out is the question. So let's just ignore KEDA HTTP for now and just stick to just CPU based auto scaling. So let's set up a little experiment like this. Let this be the high level architecture for the experiment. We just have this Azure VM, which will be our load testing client, and this will be an Azure cluster as well. So we send traffic to, it can be an ingress or if you like port forward your service to this, you could you could send traffic to this a test application. In our case, this test application is just an echo service, so it echoes back whatever is in the body of the request. It's a very simple application, a very simple lightweight container basically. It's also a Go app also in this case. So this will be the independent variables. I mean, this we'll repeat this experiment throughout, and so these are our independent variables here. This isn't going to change, but yeah, I'm going to bore you guys with numbers. So these are the results of this little experiment, and in this case, we see that. So I didn't have the table here, but even though this application deployment itself is really simple, it scales up to about 6 replicas, which is more than what's necessary. And what we realized was, if we manually scaled our deployment to 2 replicas or 1 replica, the TPS per replica here is much higher than if we scaled up to like 6 replicas. It's so in other words, by using this CPU auto scaling, we are having more replicas than what is required for us. So so in other words, it isn't efficient, because there might be cases where you need a very high TPS too, but in most cases like us, having the TPS per replica reduces significantly when we used a CPU based autoscaling. So as you can see, the yellow line is when we set our CPU target at 90%, and the blue one is at 80%, and still the TPS per replica is much higher than if we were to if we just manually had like 2 replicas or 1 replica. And yeah, so okay, so next slide. So what did we learn? So CPU usage in our case isn't always a useful metric when measuring useful work, especially in containers, when you have other things running in your container which could cause CPU to spike, but it doesn't necessarily mean that you're doing something very intensive. So then let's try KEDA HTTP right now. So in KEDA HTTP, this is currently the high-level architecture of how everything works. Uh, this this right now this is right now KEDA HTTP is at 0.1 version 0.1, and version 0.2 is going to be out soon. And this architecture represents a multi-tenant interceptor, which will be part of the new release. So here, so for example, let's say so this is how this is the high level architecture of how KEDA HTTP would work. So we have a user sending a request, and let's say you send it to the ingress. The ingress, instead of forwarding it to one of your services, it would forward it to the interceptor, and the interceptor would forward it to the services. And there is this external scaler service which looks at the queue in the interceptor, and it uses the queue metrics, or the HTTP queue length, to scale, to decide to scale, basically. So basically it uses the HPA to scale, but instead of using CPU metrics, for example, it uses HTTP queue length as the metric. So yeah, when we repeated our experiment, we could see that by using this, so in other words, KEDA scales more conservatively, whereas CPU would scale more aggressively. So the TPS per replica was much higher by using KEDA HTTP. And now we have a small demo. So KEDA HTTP also does zero to scale to zero and up. Right now, it is still a work in progress, but it is due for the 0.2 release. I'll show you guys a small demo. So we have a Go eco service which would be running, but right now it's scaled to zero. So if I see, you could see this Go eco new service, which is right now is scaled down to zero because there's no traffic. And let's hit it with traffic and see how, when we send it a request, let's see if it scales up. So this URL points to the ingress controller. So let's request. It's just an echo service, like I said. And you can see the Go echo service started running right now. So however, there's a small bug in KEDA HTTP checking whether the container is up. So the first request times out right now, but even the subsequent requests would work eventually. And yeah, of course, in the stable release, this would get fixed. So yeah, and so you would have zero scaling out of the box in the coming release. So yeah, and that's basically it. If you have any questions, please feel free.
If you have any question, you can put it in comment section, so then we can grab those comments and you can answer.
Okay. Sorry. So yeah, so we have one question: is the queue in memory? So yeah, right now the queue will be in memory, and also the interceptor could scale up as well. The interceptor is also a deployment, and it could have replicas too. So those would have the updated that those would have the queue as well. Like if you have multiple interceptors, there is an operator deployment within KEDA HTTP, which makes sure that all of the interceptors have the same queue.
Right. So, also, there can also ask, also
Yes,
did the second request
yes.
for
The second request worked. Yes, the second request works right now, as of now. It's just that the first request fails. The second and all subsequent requests would work. You're welcome. Any other questions? Also, feel free to please visit the GitHub page, and there's also a Slack channel if you guys are interested. I'll the put it here in the. Oh yeah, is there a limit for it? Oh well, okay. So that's a good question. So is there a limit for the queue, or as much as the memory available? Well, uh, yes. Well, there is. Well, so the the limit. I mean, the memory of each request. Like for example, if each of so there's this thing called the routing table, which holds all of the requests and to the relevant hosts, and that itself is very light. But yes, of course, there is technically there would be a limit to depending on how much memory is available. Yes. I'll also share the GitHub repo so that anyone who's interested can have a look at this, as well as yeah, they could contribute as well. So I'll add it to the comments. What are the scalars that could be used? So KEDA HTTP, KEDA itself has different scalars. For example, if you look at KEDA, they have like a RabbitMQ, Apache Kafka, and so like event-based scalars. But KEDA HTTP solely uses HTTP queue lengths to scale. Does that answer your question? Okay.
Otherwise, you can follow the GitHub link uh, to know about KEDA HTTP. Yeah. If you have a question, you can ask from public chat via YouTube and Facebook. Uh, Ajanth, I think we can wrap it up.
Okay, great.
So, yeah, I think no more questions at the moment.
Okay.
So, thank you very much, Ajan, for this
Thank you. Yeah, thank,
conversation. So, thank you
thank you for
everyone
having.
who's attending to this Kubernetes Sri Lanka webinar. Stay
Thanks.
safe. See you next time. Yeah, thank you.
Thank you. Bye.
Bye.